Welcome everyone. My name is Praful Prabhu. I'm the Senior Program Manager for MotionView, and it's my pleasure today to present the Motion rollout on behalf of the Motion development team, along with Scott. On the agenda today, we have the Motion 2023 release, which I'll be presenting, and followed by Scott, who will present the Inspire Motion release. Coming on to the MotionView 2023, the central focus of this release is the new MotionView interface. This interface has been available in the previous versions along with the classic desktop, but 2023 marks the official release of this interface. Along with that, we have some run workflow updates as well as changes to the entity editors. So I'll be presenting this as we go along. From version 2023, we have the new MotionView in Altair HyperMesh. This interface has been in the works over several prior releases and has been available in the install. The classic desktop is retired and will not be available by default in the installation. Henceforth, the new interface, along with the ribbons, entity browser, editor, and live simulation updates, provides new capabilities and better user experience in a modern interface. In the previous versions, this interface was based on a two-process architecture, where the front-end application would be in constant communication with the legacy HyperWorks process. In 2023, this has been moved to a single process architecture, and it offers better invoke speed and response compared to the previous versions. Old models are expected to work fine. Almost all functionalities have been migrated to the new application. The classic MotionView, as I said, accessible until the previous version of 22.3 has been phased out, making way for the new interface, which now assumes its permanent position. Both internal and external users have extensively tested this interface and provided us with valuable feedback. I thank one and all who have provided us this feedback and help us improve the software. Many of these suggestions, we have tried to incorporate them. For those who haven't had a chance to use it yet, here is a short video to walk you and get familiarized with the various tools. Okay, I hope that provided you all a glimpse of the application and are all excited to use it now. We also have a new tutorial available in case somebody is more comfortable with running through a tutorial to familiarize. There is an introductory tutorial available in the help. Moving on to the run workflow changes. The solve post-process steps we are generally refer as run workflow. We have some updates here. The changes are mainly in the analysis entity and run settings dialogues. So I'll elaborate each of these items below. Before we look into the analysis changes, I would like to provide a quick introduction to what is an analysis. It's a grouping entity or a container entity to apply events or tasks to a model. To provide an FE analogy, it is equivalent to a load step or load cases, which include a combination of loads and constraints. Similarly, in MotionView, it is possible to organize forces, motions, or subsystems that represent a particular events. Here is an example. The picture shows an example of a suspension model where different events that are studied, such as the parallel wheel travel referred to as ride, or a roll analysis or a steer analysis, these are organized into what is called as analysis. Only one analysis can be active in MotionView during modeling, but multiple analysis can be submitted to the solver at once. Creating this analysis is optional. So in this release, for each analysis, it is possible now to set up simulation parameters right in the analysis. This was not possible in the previous versions, at least not through the GUI. One had to make edits in the MDL within the analysis block. Now there is a GUI way of providing simulation parameters per analysis. In line with that, we have also introduced what is called as a default analysis. So when you open MotionView, you will see a default analysis instance, and it's an analysis instance that you'll observe. And if there are no analysis, the simulation parameters, such as the type of simulation, end time, print interval, can be specified through its entity editor. Note that this is a non-editable analysis. Except simulation settings, one cannot add any forces or motion into it, but just provide the simulation settings. Apart from this, there are some changes in the run settings. Since we moved the analysis types, end time, and print interval to the entity editor, these options is no longer available in the run settings dialog. The advanced settings is renamed as global simulation settings because that's what they are. It's a simulation settings at a global level, which provides defaults for all the analysis. There was a request to expose this output directory where the run is being executed to be shown upfront. So it's available now. Earlier, the run were executed through subfolders. That means whatever run name we provided, there would have been a subfolder. And if there are multiple analyses, there would have been multiple subfolders. So this arrangement has been removed now, and runs are directly executed in the output directory. So just here is a kind of a video summary of all these changes that was described now. So this video should help understand the workflow better. So the default analysis, if there are no analysis in the model, one can select the default analysis and change the values in the entity editor. And then you follow the run ribbon to execute the run. If there are multiple analyses, select those analyses in the browser and make edits in the entity editor. Here is an example of a landing gear which has two analyses, one to study the retraction and another to study the landing mechanism. So for each of these takes different parameters as far as end time, print interval, or other simulation parameters. So these can be set up using the entity editor for these analyses, and then use the run ribbon to run these multiple analyses all at once. The analyses are executed sequentially, and its animation, its progress can be seen visually in the graphics area. Once the run is completed, the MotionView is in a review mode, and you can review the animation. Activate the analysis for which you want to review and enter the review context and animate those simulations. When you save the model, the result information is saved in the MDL now for each analysis, so that when you load the model and you want to review the last run, it can be done now. Just go to the analysis and go to the review context, and these animations can be retracked. Apart from that, there are some changes in the run history. Earlier, it was a flat list. Now, the run history is arranged or categorized based on the model. So for each MDL, whatever runs were executed earlier are listed under each model category. There is also a search tool available for a convenient search for a specific run that was executed earlier. The run history is accessible from this calendar icon on the run ribbon. Next, on the entity editor, we have more entity editors now for many other entities such as systems, analysis, datasets, templates, etc. Very few set of entities still are using panels such as curves and deformable surfaces, solver arrays, and macros. So in the upcoming releases, these will also get a new workflow and a new entity editors. So the relying on panel will go away, and the panels for core MotionView will be removed in the upcoming release. So to summarize, in MotionView 2023, the classic desktop retires, and we migrate to the new interface. There are updates to the run workflows and entity editors. That brings end of my part of this session. Now I'll hand over to Scott.
Thanks, Praful. So it's been a good release for 2023 for Inspire Motion. I'll start off kind of bridging where Praful left off, in that the migration, the retirement of Classic and the move to 2023 MotionView. So by default now, if you have the 2023 MotionView Unity version installed and you have the HyperWorks path set appropriately, when you use the option in Inspire Motion to open the model in MotionView, it will open in default in MotionView 2023. Okay, so when you get the products installed, check it, make sure you're not launching Classic, And if you have any questions, please reach out on how to set the path for the environment variables. Okay, so we in the previous release, we implemented co-simulation, input-output signals, this dialogue that we can use to generate input and output signals for a twin activate co-simulation, state space matrices output. And now we have FMU block support. So it's the same dialogue, it's the same workflow. We now write out an FMU package that could be read, for example, into MotionSolve or twin activate. We've also implemented a table for flexible bodies. In the past, or the previous release, we only had access to change the different parameters through the flex body. In a couple of the parameters were accessible through the micro dialog. Other parameters were through the property editor. We've now combined them, so we're now consistent. We have, joints, couplers, rigid groups. Everything has a table associated with it. And through this table, you can change any of these values. And you can also do group selection as well. If you hold down the control or the shift keys, you can do multiple changes at once in here. So it makes it easier and quicker to generate flexible bodies and also get a nice summary of the different parameters of each flexible body in one view. Okay, so I know that some of you are long anticipating this. It's not done, but I'm putting this up here because there was a lot of work done by one of our developers this release. Magdalene Anastasiadou did a lot of work in setting up the different variables, prepping Inspire Motion for entry into design exploration. So in the next release, we anticipate we're going to put the hooks into design exploration. You will not see these variables right now, but like I said, I did not want this to go without saying there was a lot of work done behind the scenes on this. There's no feature to really show, but I think it's important to praise the work of one of the developers, and the stage is set for making design variables implemented into Design Explorer in the next release. Okay, so now we have another new feature as part of the profile editor called multi-signals. So for when you want to create multiple step functions or functions that are not, say, a step-dwell step, a simple harmonic, sometimes you need to write custom expressions through MotionSolve. And if you know how to write that syntax, that's great. But a lot of Inspire users don't. And what, for example, would you do if you wanted to have a step-dwell step and then another step along with that? Well, you'd have to write a solver expression to do that. So now we have another function in the profile editor called multi-signal, where you can build these curves from scratch. And so what I'm going to do is I'm going to wander off here into a quick demonstration I have. Have to move my model up, I think. Go. Okay, so, but right here, if I double click this motor on this this arm right here, I'm gonna have to move this dialog up. You can see that for the movement of this motor right here, a solver expression was used. Why? Well, because it's not a traditional step-dwell step or step function. It's a combination of two step functions. So let's go ahead and let's run this. If I can get to, my screen is quite enlarged here. Just take a look at what this thing does. And then what we'll do is we'll turn around and replicate it. That's not exactly what I wanted right there. Sure what happened with that. Right. Well, let's see what it would do to replicate this function right here. All right. For those of you that are familiar, there's two differences in here. There you have the time. Time is absolute, right? But the value of the angle, for example, is relative. So we have absolute and relative mixed into this function right here. So if I go into the multi-signals right here, okay, so I have the same layout as I would if I was, for example, in a step function or a step-dwell step. So I'll go back to multi-signal, and then I'll go ahead and add my first function in, and I'm saying go down -50 degrees, starting from 1.25 seconds, and I'll give it a delay of 1 second. Okay, if the curve doesn't show up, you can click the lightning bolt down here. It will auto calculate the end time. And all the values on these curves are draggable, right? So you can use the draggable lines right here to move things around, just like we could in with all previous functions. So now I'll go ahead and I'll click and add another function onto this. And for this one, I want the value to be relative to the previous value. So I'll say -90, which should be an absolute value of 140. Okay, so you can switch between these. And then the absolute, I'll say from 3 seconds and a 1 second duration. I do my auto calculate, and there's my solver expression that I just replicated with multi-signals. Okay, so there's some nice behavior in here. If you drag these, like I said, it'll drag the whole curve. If you hold the control key down, it'll only change the start time of that curve, for example. So I can drag all of these over, hold the control key, just change the one individual function. So I can right click on this. I can say add another dwell step in here, and I can just continue building these. And then of course I can save these off to a table if I'd like. Okay. Right. Here's an example that shows you how we combine 3-step functions into one very quickly with this tool. The other new feature we have, I would say new features and behaviors, is surrounding joints. So we have new joint graphics for Inspire. We do show contact faces like we had in the previous versions, but we only do it for the contact type joint, not for the other traditional kinematic joints. So this is now better aligned with MotionView and consistent. It also gives a better representation of the actual degrees of freedom that you have on the different joints. Okay, when you create the joint, it's still the size of the graphic is based off of some of the heuristics, the feature sizes of the parts that you select. So we've implemented this sizing manipulator where you can click and drag and change the size of the joint graphic. We also have another mode for creating joints. In the past, when we had a large model, we would tell a user, you might want to hide some of the parts before you detect joints in the model. Why? Because it will go off and search all the parts, and it might take a while. Sometimes you realize that it's taking too long. A user has to kill the joint find, and then hide parts, find the joints, show some parts, find the joints. And it was just a process that wasn't really in good workflow. So what we've done is kind of baked that process into the UI for the guide bar. So when you first come into the joints detection, it'll be defaulted to all parts, and it will not auto find automatically. You have to click the find button. Why doesn't it auto find automatically? Well, because a user may want to change it to select parts. If you change it to select parts, you can walk through the parts individually and create the joints. I'm going to do a quick demo of all of these features here that I'm summarizing for joints in just a moment. And then finally, we have joint edit options. So we now have the ability to move and reorient a joint in Inspire. So if you click the joint and you're in edit mode, there's the move tool that's on the micro dialog. You click the move tool, it invokes the move tool on the graphic, and the move tool also represents the axes that are used by MotionSolve. As some of you know, there's I and J markers for these parts, and the markers are used to calculate all the information for outputs and things like that. So the move tool is basically a mirror representation of what that marker orientation looks like in the model. I'm going to go ahead and toggle over to a simple model here. Now, there's lots of good cases for why we have these joints now. Now we have the ability to create joints in models where there's not features necessarily. So here I'm in a simple scissor mechanism. And if I go into the joints context, notice how it comes into all parts. I can click find. And
Scott?
Yes.
Scott, we are not seeing your model.
Thank you, Praful. Thank you. Sorry about that. Okay, so when I came into the joints tool here, it defaults to all parts. I can click find. This is the same behavior as we had in the past. The only difference is it's not going to auto find as soon as you come into the tool. Now you can also change this and say select parts. Well, what is this? Maybe you prefer to have a gradual crawl, walk, run approach to building your model. This fits nicely with what we teach our users in training classes. So if we click a part, click another part, it looks for the features between those parts. So this was always a problem point in Inspire Motion, right? So it picks up a flat face right here. And if I click it in the old version, I really couldn't, I only had options for, say, a planar or an unknown joint. But now I can, by default, I create the joint, it puts a planar in there, okay? But I can take and I can switch this over to a hinge, for example, click the move tool, and then drag it and allow it to snap into position right there. I can also take and move the location of the joint. Sometimes joint locations are determined by the feature heuristics, and they're not entirely correct 100% of the times. So you may have to verify that the joint is where you want it, because load distribution through the model can be different. So then if I click the next part here, I get this cylinder. Now, granted, there's no holes in this cylinder right now. Okay, so if I do this, I have a cylindrical joint. And by that, I mean, this part right here doesn't have any hole in it. So there's no feature in there. So the point here is somebody is conceptualizing perhaps, and they're not putting all the features into the model, but they still have a way that they can go through and they can build these different parts or joints. Okay. And then you can sit here and walk through and do what you need to on these different joints all day long. You don't have to size these graphics like I am. These graphics are just visual. You can still just leave the defaults and run like you always could, but now you have a good visual as to really what's going on with the different joints. Okay. And I believe that's all I had for my presentation.